Working? Good.
So our next speaker is Josh Combs from Azure Minerals, who's going to be talking about the recently discovered Andorra deposit.
Hey, yeah, so I'm going to be talking about the Andover deposit. Just give, I need to click. Just a few acknowledgements, and particularly thank the company for sending me here and allowing me to publish the stuff that we've been working on. I won't go through the list, but I'll just give a shout out to the mapping team, because they've done an excellent job, and sort of a lot of their work forms the foundation of the research. So just a quick overview of the Andover complex. So it's a mafic ultramafic complex, Archean in age, in the Pilbara. It's just south of Roebourne. So Roeburn's actually at the top of the map there. On a broad scale, it comprises dunites and prittites in the east, and it fractionates through to gabbroids in the west, including to the west of our tenure. There's a few iron, titanium, vanadium deposits. So I'm going to be focusing in on sort of the southwestern portion of our tenure, because that's where our Andover discovery was made. So you can see the insert there. So that's where Andover was discovered, and it's where a lot of the prospects that we've drilled, we've got a lot of data from them, and we've also done a lot of mapping through here. So our understanding of the system is basically derived from this area. And in particular, I'd like to point out Symposium skyline, because I'll be talking about a bit of evidence from there. It's about 3.5 kilometres away from the Andover deposit. And then down in the southwest, you've got the Andover deposit and the Ridgeline deposit, a few hundred metres apart. So just a few key points before I go into the model. So the mineralisation at Andover is hosted in taxitic gabbros. They're quite fractionated, quite low MgO, contain websterite xenoliths, and locally contain disseminated and globular sulfides proximal to the deposit. Just a bit of a zoom in on a few of the taxitic textures we see near the deposit. So you've got a lot of websterite xenoliths, some of which contain magmatic sulfides themselves. And this is just an example of a few of the textures we've been seeing. Try not to dwell too much because I've got a lot to cover. And just a brief shot of some of our massive sulfides there. So although it's hosted within the taxitic gabbros, when we took some thin sections and did some work on the massive and semi-massive sulfides, we found that they all contain websterite xenocrysts and xenoliths throughout. And you can see in places, particularly around Symposium skyline, which I think is sort of a deeper, earlier part of the system, you can see a lot of magmatic textures with these sulfides. So here you can see the websterite being pulled apart essentially by the sulfide melt. There's plenty of examples. I just don't have time to show them all. So I'm going to go through basically the model that we've worked out. It's a little bit simplified. There's a few nuances, but on a broad scale, it explains all our major observations that we've seen so far. So the first stage was the emplacement of the overall intrusion and the accumulation of the dunites and leucolites in the east, and it sort of fractionates through. So we have some early gabbros, which you can sort of, there's a bit of layering in the north and sort of to the west of our tenure, fractionates right through to sort of some iron, titanium, vanadium bodies, which were drilled out in the 60s. At some point early on in the history, we had some weaknesses forming in this early part of the complex, which were very important for sort of focusing later intrusions. And we also had some granites coming up at a very similar timing. We've done the geochronology on them, and they basically overlap with our mafic system in age. So the first proper step of the Andover mineralization was sort of a sort of later, more primitive pulse coming in and cross-cutting all of these all of these early rocks. So we see it cross-cutting the gabbros as well as the lozolites in the east. So I've just got a bit of an example of basically the early pulse, which I think is the source of the sulfides for the Andover deposit. So sort of I really like this. We see these lines of evidence throughout. I just really like this particular intercept because we see so many features in such a short section of core. So first of all, I'll draw your attention to sort of these interstitial sulfides, clearly magmatic, forming sort of as the intercumulus for the pyroxene and olivine crystals in this websterite. But in the same rock, we get brittle, we see evidence of the sulfide sort of brittly fracturing this websterite and moving around after the websterite's at least partially consolidated. So we know that these sulfide melts were still mobile even as the websterite had sort of crystallized and consolidated. So that's sort of important for the next part of the deposit formation, and that was the intrusion of this taxidic gabbro, which is really our carrier melt. So we've done a lot of mapping across the Andover complex, and we see these features both in core and in outcrop. It's really spectacular. Got 70% odd outcrop, so we see a lot of these features all over the place, but we see a really high degree sort of interaction between this taxidic gabbro and the websterites that I think are the source of these sulfides. So you can see here, we've got a taxidic sort of intrusion cross-cutting the websterite, and you can see the evidence of the weathered out sulfides in the websterite there. We got a really nice platform. This is one of my favorite outcrops in the whole complex. And you can see here, we've got a websterite essentially being intruded and chewed up by this taxidic intrusion that's coming through at a later point. So we see this as kind of the first stage of the taxite chewing up the websterites, and then we see elsewhere you start to disaggregate these websterites. So you can see here that's slowly getting pulled apart, and then a bit more distally you'll see evidence of xenoliths left behind. And of course we get magmatic sulfides being, I think, directly taken from this still liquid sulfide melt that formed and got its nickel from the websterite. So this is one of my favorite bits of geochemical information from Andover. So this is a plot of all of our whole rock assay data above 5% sulfur. And you can see a few populations there. So you can see, I think this population has basically no metals. I think that's potentially related to a source for the sulfur saturation. We've got a low tenor population here, which in the case of these two blue populations, they're a low tenor horizon that sit above the main Andover and ridgeline deposits. And then we've got these populations which form the mineralizing system at Andover. And you can see I've color-coded them according to how they're labeled in this map here. And you can see there's a distinct systematic variation of the nickel tenor from east to west. where you're gradually upgrading the sulfides within this taxitic melt as it progresses. So we've got a taxitic gabbro full of high tenor sulfides. What do we need? We need focused deposition to form a deposit. So we've currently identified and drilled out two deposits where we've got a couple of trap sites. So Andover, we see that there's a change in direction of the intrusion associated with where the mineralization is. And at Ridgeline, we've got cross-cutting structures. So we've got the main structure, the taxites ripping along, and then the cross-cutting structure sort of defines the plunge of the sulfide accumulation. And then we do get sulfide fractionation within the ore body itself. So we end up with bands of chalcopyrite-rich material and veins cross-cutting the host gabbro as well as this copper-rich melt moves around. You can see it in the whole rock data as well, where you see that this is again all of the data from the entire complex, and you can see an upgrading of the system and then a trend for the fractionation. So this is one of my favorite tools that we've developed from our understanding of the nickel system at Andover. So essentially what we have is a bit of a contrast. We've got a highly fractionated gabbro and some very primitive sulfides present within them. So there's a bit of a dilemma there. That's an unnatural association. So what we've managed to do is we've managed to develop a geochemical proxy that maps the primitive nature of the sulfide and maps we've got several known proxies for mapping the primitive nature of the intrusion. In this particular example, I used magnesium number because then we can see some additional features, which I'll point out in a second. So a natural fractionation trend that you might expect, and we do see at Andover, is as you sort of fractionate the intrusion, the primitive nature of the sulfide decreases, and you sort of move from these ultramafic dunates, dunates and pridatites through your gabbros, which are these sort of blue and green colors, through to your granites down here. But what we see instead in our data is that when you add primitive sulfides to a fractionated gabbroid, you end up with this sort of unnatural trend in the chemical data. So this is whole rock chemical data, which sort of pulls. You basically end up with a fractionated magma with primitive sulfides in it. And the reason I use magnesium number is because you're putting iron in the system. You can see the trend of sulfide accumulation in there as well. But you could equally use chromium, vanadium, or something like that. But I just have a preference for being able to map the sulfide accumulation as well. So what? Well, the beauty of this system is it essentially acts as a proxy for nickel tenor. So you can see here, there's quite a nice distribution. So you can see the low tenor horizon comes up with a low response on this prospectivity index. And you can see it highlights the deposit. The beauty of this system is that the gabbros maintain that signature even in the absence of sulfides. So you can see here, this is the data set filtered for less than 1% sulfur. This is for less than 0.3%. And you can actually still see that these rocks have seen your high tenor sulfides. It's a highly effective tool that we've now sort of applied to the whole region. We've got a 4,000 surface sample database, which we've used to map out this system in 2 dimensions. Sorry, I've got to power through a little bit. So we've sort of leveraged this understanding of the nickel system in Andover quite successfully. We recently made a discovery, well, when I say recently, about a year ago, made a blind discovery at Ridgeline on the back of this understanding. So this was fairly on. You can see it's hole 38 at Andover. It was a bit of a step out, a couple hundred meters to the west of known mineralization. Hole was planned to go to 650 meters. My colleague, Paul Smith, absolute legend, noticed some very subtle taxitic textures in the last run, he was like, cool, I'll extend the hole, which is quite a brave strategy. And then ended up drilling some more tacksites, extended the hole another 150 meters. Downhole anomaly from that extension led to the discovery of ridgeline, which is really cool. I won't go into the delineation of ridgeline. I'll just sort of leave you with this slide, which is some geochronology work that we did. So we basically took 2 samples of taxite from between massive sulfide horizons. So both of them were about 100 meters apart, got zircons out of them, came out with quite a robust date. Both of them overlapped. So we ended up with quite a nice date. And these bottom images I absolutely love because we've got clearly magmatic zircons growing in the same quartz crystal as our sulfides. And we got some in situ dating on those as well, which lined up with the bulk of the data points. So yeah, I'll leave you with that. Well, I don't know. I'll put this question out to you. We couldn't find any definitively dated lemon magmatic systems, magmatic nickel systems older than this, but I do welcome a bit of robust debate on it. Yeah, that's it. Thank you. Any questions? Oh, sorry.
About some you were using as a primitive. Is that a secret company?
Yeah, yeah.
Why you didn't tell us what?
Sorry, yeah, no, I couldn't. Yeah. Oh, yeah. Yep. Sorry, it's a vector that we use with the whole rock data, but I'm not really allowed to talk about it. Sorry, I would love to. Yep.